So, dear students, let us continue our discussion on problems on motion in a straight line. And here comes the 11th question. In the last session, we stopped the discussion after 10th question, and this is the 11th question that we will take today. So, question number 11 is as follows. A car moving along a straight line with a speed of 60 km per hour is brought to rest within a distance of 15 meter. Calculate the deceleration. Again, an easy problem. So, here we have a car which is moving in a straight line initially with the speed of 60 km per hour, right? So, initial speed of the car is 60 km per hour, and this 60 km per hour moving car is brought to rest. How do we bring the car into rest? We apply the brakes and hence car comes to rest. So, after applying the brake, the car doesn't stop immediately, instead it travels a certain distance and then finally stops. What is the distance traveled by the car from the point of application of brake to the point where it stops? It is 150 meter, right? And at this point where the brakes are applied, the speed or velocity of the car is given to be 60 km per hour. At the final point of the motion, this velocity of the car is 0 km per hour or 0 meter per second, both are fine because the car has stopped. And now what we need to calculate is acceleration. See, they are asking us to get deceleration. You know that when we take acceleration, deceleration, retardation mathematically, all of them are nothing but a value, okay, small a value. So now using that, using equation, so equation of motion, first equation of motion, we can obtain a. But before that, yeah, displacement of the body from here to here is s is equal to 150 meter, right? Okay, and now here displacement is given, uh, u initial velocity is given, final velocity is given, acceleration is asked to find. We do not have any idea about time. So, first equation of motion will not help us in calculating this, right, because we do not have idea about time. So, we need a formula which will connect v, u, a and s, and the formula is v squared minus u squared is equal to 2as. Before that, as you can see here, velocity is in kilometer per hour, displacement is in meter. So, I need to convert this velocity from kilometer per hour to meter per second. So, u will be equal to 60 into what is 1 kilometer per hour? 1 kilometer per hour is 5 by 18 meter per second. In the last session, we discussed about the conversion factor, right? The conversion factor is 5 by 18. So now we have all the quantities in the same unit and hence we can go for solving A. So formula is v squared minus u squared is equal to 2as. V is 0 squared, which is 0, minus u squared. So let me simplify this a bit before I put it into squared. See, this is divisible by 3, right? 3 6, isn't it? Or directly I can divide it by 6 itself. 6 3s are 18, 6 10s are 60. So it is 10 into 5 by 3, 50 by 3, right? Let me keep it as it is, 50 by 3 meter per second. So it is 50 by 3 squared is equal to to A. What is A? A has to be calculated. Displacement S is 150 meter. Now here we have minus 50 into 50 divided by 3 squared is 9 is equal to 2 into 150 into A. Now 51s are 50, 53s are 150 and 2 ones are 2, 25s are. So what we are left with in the LHS is 25 by 9 and in the RHS we are left with 3. So if I send 3 here, it will become 25 by 27 is equal to A, minus 25 by 27 is equal to A. So that's it. So that acceleration is minus 25 by 27. You can make use of calculator to get the value. So acceleration is 25 by 27, which is equal to, as you can see, 0.9259, which I'll take it as minus 0.926 meter per second squared. So this is the acceleration of the car, but what they have asked us to find is deceleration of the car, right? So nothing else. Therefore, this if minus 0.926 meter per second squared is the acceleration, therefore deceleration of the car is, you just leave the negative sign and write the rest. With that would be 0.926 meter per second squared simply. Okay, that's it. See, even if they ask retardation, both are one and the same. You can stop writing at this point, 0.926 meter per second squared. So this is the solution for 11th question. Next, moving ahead for the 12th question, here we have it. The velocity of a car increases from 18 km per hour to 54 km per hour in 12 minutes. Okay, huge time, 12 minutes it is. Assuming the acceleration to be uniform, calculate the distance travelled. So now in this question, what and all are the given factor and ask the factors. See, the velocity is increasing from 18 km per hour to 54 km per hour, which means initial velocity is 18 km per hour and final velocity is 54 km per hour. Time taken is 12 minutes. Okay, normally it won't take this much of time. Okay, this might be seconds, but yeah, fine. Even if they give minute, we should be able to solve, because this will become 720 seconds. Okay, let me make it second. Let me solve it as it is, no problem. I'll convert it into seconds, and I should convert velocities into meter per second also. Okay, first let me write the data. So u is given, I have written. V is given, I have written it. Time is given, 12 minutes, I have written. Assuming the acceleration to be uniform, calculate the distance travelled. S has to be calculated, displacement. Okay. So we can go with the average velocity formula. Average velocity into time taken is the displacement. Before that, we should convert these factors u and v from kilometer per hour to meter per second, and time from minutes to seconds. Or we can also do one thing, we can convert minute to hour. Okay, even if we convert minute to hour, then also we will have all the factors u, v and t in same units, kilometer and hour, and hence we can get displacement in kilometer. Okay. So let me convert time itself into hour. What is the conversion factor for minute to hour? See, 1 minute is 1 by 60 hour, isn't it? Because 1 hour is 60 minutes. So 1 minute is 1 by 60 hour, which is going to be 12 ones are 12, 12 fives are 60. So time in hour is 1 by 5 hour. I will not substitute, simplify this, I will keep this as it is. Okay. So now I have u, v and t, all the factors in same unit, hour, 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 kilometer, kilometer. So, and now what I need the formula, I need a formula which will connect S, T, U and V, which is that formula. So S is equal to average velocity into time. What is average velocity? V plus U by 2, average velocity into time. What is V? Final velocity given here 54 km per hour, plus U is initial velocity 18 km per hour divided by 2 into time is 1 by 5. Okay. 54 plus 18 is going to be 72 by 2 into 1 by 5. Then it is 2 ones are 236. So what we have is S is equal to 36 by 5, which is going to be 7.2 kilometer. Okay, 7.2 kilometer is the answer. So this is about the 12th question. Since they have asked us to calculate only the distance traveled, I can go with this formula. If they had asked us to calculate the acceleration also, then we should have first calculated acceleration using v is equal to u plus at. If we put that, we will get a. Okay. Since they have not asked us the acceleration, I have not calculated. If they had asked us to calculate the acceleration, we must calculate the acceleration also along with the displacement. Okay, fine. So this is about 12th question. Right, next 13th question is as follows. A body starting with the velocity of 10 meter per second accelerates uniformly for 60 seconds. If the velocity acquired in this interval is 250 meter per second, find the acceleration and the distance traveled. So here this question has a bit twist in the given factor. First given factor is easy, a body starting with the velocity of 10 meter per second, which is u, initial velocity of the body is 10 meter per second. Then from 10 meter per second, the body uniformly accelerates for 60 seconds, time t is equal to 60 seconds. And at the end of the motion, if the velocity acquired in this interval, which means velocity acquired in this interval of time 60 seconds, in this 60 seconds is 250 meter per second. See, they are not giving us the total velocity acquired from the beginning of the motion. Total velocity acquired is simple, 250 meter per second, that's fine. But if the velocity acquired in this interval, in this 60 seconds is 250. See, in this interval it has acquired 250 meter per second. It already had 10 meter per second speed. So together now 250 plus 10 is 260 meter per second, which is the final velocity. But how do we write it mathematically? Velocity acquired in this interval, okay, particularly they have given in this interval, in the interval of just 60 seconds, which is v minus u, okay. Final velocity minus initial velocity is the velocity acquired in the given interval. If they simply gave, if the velocity acquired by the body is 250, then v becomes simply 250. Okay, because then they are uh, telling you about the total velocity acquired by the body, right from the rest. So now what they have given is v minus u, which is equal to 250 meter per second. What is u? U is 10, so v minus 10 is equal to 250 meter per second. So v is equal to, no need to write the unit, v is equal to minus 10 comes here, becomes plus 10, 250 plus 10 is 260 meter per second. So you have u with us, v with us, we have u and v now, and we also have t, which is 60 seconds. What we need to calculate is acceleration and distance. A is equal to question mark, s is equal to question mark. Okay, now formula for acceleration, I'll directly put it. A is equal to v minus u by t. What is v? Final velocity. See, I can directly put v minus u is equal to 250 here. That is also fine. 250 by time is 60 seconds. One of the 0 cancels. So A becomes equal to 25 by 6, which is 4.166. 4.167. It goes on recurring meter per second square. So this is acceleration of the body. And displacement, I can use any formula. S is equal to ut plus half at squared, v squared minus u squared is equal to 2as. And then we also have one more, s is equal to u plus v by 2 into t. So now we shall make use of any of those formula to write s is equal to, I'll take s is equal to ut plus half a t squared itself. U 10 time is 60 plus half into acceleration is 4.167. I can put it as 25 by 6. Okay, that is also fine. Into t squared, 60 squared, right? So 10 into 60 is 600 plus half into 25 by 6 into 60 squared is 60 into 60. 6 ones are 6, 6 tens are 60. And then you have 600 into 25. Okay, or once again this 6 has got cancelled. 2 ones are 2, 2 5s are 10. 5 into 25 into 60. Okay, 600 plus 5 into 25 into 60. 5 into 25 into 60, which is going to be 7,500. 7,500. So total displacement of the body is going to be 8,100 meter. Okay, better keep it in meter itself, no problem. Don't need to convert it into meter. Keep it in. Don't need to convert it into kilometer. You can keep it in meter. Okay, that is fine. So 8,100 meter is the total distance traveled by the body when it acquires a velocity of 250 meter per second in this interval. In this interval, it is acquiring 250. Okay. If the total acquired velocity was 250, then final velocity will be directly 250. Okay, you should keep this in mind. If they give particularly in this interval, then final velocity will be 250 plus 10, initial plus acquired. If they give simply, if the velocity acquired after 60 seconds, okay, then v is directly 250. Okay, right. This is 13th question. Next question, question number 14 is as follows. A car moving along a straight line with a speed of 90 km per hour is brought to rest within a time of 3 seconds. Calculate the retardation and displacement. Right. So initial speed or initial velocity of the car is given u 90 km per hour is brought to rest within a time interval of, so time of the motion is 3 seconds. Calculate the retardation, acceleration and displacement. Yes. So here we have u in kilometer per hour and t in second. So we should convert initial velocity from kilometer per hour to meter per second, which will become 90 into 5 by 18 meter per second. So here we have 18 ones are 18 5s are 5 5s are 25 meter per second. So this is what is the initial velocity in meter per second. So now I have u and t, and we have one more formula, it is one more factor given. It is brought to rest, which means final velocity is 0 meter per second. And now we can make use of the formula. V is equal to u plus at to get a first. So V is equal to u plus at. V is 0. You can directly take a is equal to v minus u by t, that is also fine. Okay, the same formula. U is 25 meter per second. After converting, you should put the value plus a into t is 3 seconds. So a will be minus 25 by 3, okay, which will be 3 minus 8.33 meter per second square. Okay, minus 8.33 meter per second square. What is this? This is acceleration of the car. So deceleration is, therefore deceleration of the car is, you remove the negatives and write the rest, simply 8.33 meter per second square. Okay, easy. Next, displacement should also be calculated. How do we do that? Yeah, we can go for two ways. One is s is equal to ut plus half at square, and the other is v squared minus u squared is equal to 2as. Yes, we can also make use of s is equal to v plus u by 2 into t. Okay, right. I'll go with s is equal to ut plus half a t squared. So when we put the values here, s becomes equal to, what is u? U is 25 into t, t is 3 plus half a. What is a? A is minus 8.33, keep it in mind. Okay, deceleration is 8.33, but what we need to put here is a, acceleration, which is minus 8.33 or minus 25 by 3. I'll keep it minus 25 by 3 into t squared. T squared is 3 squared. So 25 into 3 is 75, minus into plus minus half into 1 of the 3 gets cancelled. Okay, 3 squared is 3 into 3, 1 of the 3 got cancelled. What we are left with is 25 into 3, which is 75. So 75 minus 75 by 2. 75 by 2 is going to be 37.5. So the difference of them is again 37.5 meter. So this is the displacement of the car. Okay, and this is the deceleration of the car. These are the answers which they are asked for in 14th question. Okay, the next question is as follows. A stone falls under the influence of gravity. After 2 seconds, it strikes a glass plate held horizontally. In breaking through the glass plate, the stone loses half of its velocity. How far will the stone travel in next 3 seconds? Okay, the situation is as follows. Here we have a stone, and the stone is falling freely under the influence of gravity. And while it is falling freely under the influence of gravity, after 2 seconds, after time 2 seconds, what it goes through is a glass plate. It falls on a glass plate after 2 seconds, and the glass plate breaks. And while breaking this glass plate, this stone loses half of its velocity. So initial velocity at this position, let me name the points as A, B before falling on the glass plate, C after coming out of the glass plate, C, and loses half of the velocity at this point and continues to fall again. While continuing to fall again towards the ground, it travels further distance for downwards, and they are asking us to get the distance traveled by the stone after 3 seconds of breaking through the glass. So after breaking through the glass and traveling for 3 seconds, what is the velocity at this point? Let this point be d. So now what I will do is I will divide the entire motion into 2 parts. First part from A to B, the second part from C to D. First I will work for the motion of A to B. When it comes to motion of A to B, here you can see that initial velocity is 0 because it is falling freely, right? And time is 2 seconds. Acceleration of the stone. What is the acceleration of the stone? When the stone falls downwards under gravity, acceleration is equal to plus g, right? Which is A is equal to 9.8 meter per second squared. So from A to B, initial velocity is 0 meter per second. Final velocity has to be calculated. Why do we need this final velocity? Because if we get this final velocity, half of this final velocity will be initial velocity at C. That is why I need V. So V has to be calculated. We are given with U. Time given is 2 seconds. Time from this point to this point is, time taken is 2 seconds. And now you can see you have U, V and T with you, and what we need to calculate is V. A is 9.8 meter per second squared. We need V. Very simple, first equation of motion. V is equal to U plus AT. U is 0 plus A is 9.8 into time is 2 seconds. So final velocity of the body for the motion from A to B is going to be 19.6 meter per second. So this is what is V. Right. So this point, at this point, before it falls on the glass plate, it had a velocity of 19.6 meter per second. When it breaks through the glass, half of this velocity is lost. So when I take the motion from C to D, from C to D, at this point the initial velocity is half of this velocity. What is this? 19.6. So initial velocity at point C will be 19.6 by 2, which is going to be 9.8 meter per second. So initial velocity at point C is 9.8 meter per second, and the time for which it still falls down from C to D is 3 seconds. And while it falls down, it travels certain distance which has to be calculated now. And acceleration is 9.8 meter per second square again, because it is falling under gravity. So now acceleration is 9.8 meter per second square. Okay, so what I need is S. I have U, T and A with me. Very simple. Formula is S is equal to ut plus half a t squared. U 9.8, T 3 plus half into A 9.8 into T 3 squared. 9.8 into 3, 29.4 plus 3 squared is 9. 9 into 9.8 by 2. Okay, 9 into 9.8 divided by 2. That is going to be 44.1. So this 44.1 plus 29.4, it is going to be plus 29.4, 73.5 meter. So in the next 3 seconds from C to D, the body travels a distance of 73.5 meter, and that is what is asked. How far will the stone travel in next 3 seconds? How far is 73.5 meter of distance is traveled by the stone. So this is 15th question's solution. So this is about today's problems. We have solved 5 problems today, and from the next session we will take the remaining problems. Thank you.